All right.
Dude, I'm so taking it.
Okay. So I want you to go to the back of page 13. The back of page 13.
Go to the Coliseum. You see a man fighting a lion.
We're on the back of page 13. Check your understanding. Let's see if we have any understanding. Here we go. Patty's riding a Ferris wheel. Her distance above the ground after T minutes is given by this equation. So the ordered pairs of the equation are minutes, comma, feet above the ground. The equation's already written for you. Usually we have to write it ourselves. Minutes, feet above ground. Okay, so we've got y equals negative 20 cosine pi over 4. I'm going to write it the way I normally do. Pi over 4t plus 23. Okay? Now, let's talk about this curve for a moment. What is the amplitude of this curve? 20. What is the period of this curve? Always 2 pi divided by that number. So 2 pi divided by that number is how I get my period. Because the normal period is 2 pi, and that coefficient is a divider. So what is that? 8? So frequency would be 1/8. What about my midline? What's my midline? Y equals 23. Right? Let's graph it. Midline's 23. Period's 8. So that means that from start to finish is 8, right? So this is a cosine with an amplitude of 20. So it's going to go up to 43 and down to 3. Right? It's a negative cosine. Remember, cosines start at the max or the min. A negative starts at the min. So my cosine is going to start here, and it's going to end there, 1 period of it. And in the meantime, it's going to go up to 43 and then come back down. So that is a picture of my cosine. Where would the maximum be? 4. And then these points where we cross the midline would be at 2 and 6. Everybody okay with that sketch? Now, let's answer the questions. Why does it make sense that this problem is being modeled by a sine curve or a cosine curve, a sinusoidal function? Why does it make sense? It's periodic. Ferris wheel goes round and round and round, and her distance from the ground is getting bigger and then smaller, and then bigger and then smaller. Estimate her height above the ground after 5.5 minutes. Well, we could truly estimate after 5.5 minutes, isn't she like about right in here? So maybe what, around 28, 27, 26, somewhere in there? We could also do what? We could do it on our calculator, because if we put time 5.5, we type this in, it should give us the answer. Now, make sure that your calculator is in radian mode. You need to be in radian mode. Because when I said the period was 2 pi, that's radians. So, negative 20 cosine pi divided by 4 times 5.5 plus 23. Ooh, we were low. It's 30.65. When you said 28, somebody I think said 28 or 29, something like that, you were close. But it's 30.65 feet. 654.
What would happen if we weren't radians?
You'll get a different answer.
What's the equivalent?
Well, it's gonna do it in degrees. And you're not inputting a degree, you're inputting a radian. So back here, I would have had to find this coefficient, doing 360 divided by, actually, pi over 4 What is the maximum height that Patty is ever off the ground? Maximum height she's ever off the ground is 43. What is the minimum height she's ever off the ground? 3. How come it's not 0? Because she's not sitting on the ground, right? She's sitting on a bench of a Ferris wheel that's 3 feet off the ground, apparently. What is the diameter of the Ferris wheel, and how do you know? What do you think? 40? Why do you think the diameter is 40? So, since the midline is at 23, if you think about the Ferris wheel, think about this being 23, going around the Ferris wheel. The highest up you're going is 43, the lowest you're going is 3. So isn't the diameter going to be 40? The radius is 20. How long does it take the Ferris wheel to make one complete revolution? That's its period. So how long does it take? 8 minutes. Okay? All right. Skip page 14 and go to 15. Multiple choice, kind of, but there are lots or more, there could be more than one option. So let's look at that picture that's drawn. Could it be could it be just plain y equals cosine x? Uh-huh. Yeah. Because doesn't cosine start at the top? And at 0, we're at the top? Could it be a negative cosine x? No. It's positive. Now, it could be negative if we moved it around, but not without phase shift. So it is positive cosine, it is not negative. How about sine x minus, or excuse me, x plus pi over 2? Now wait, what does x plus pi over 2 do? Moves me backwards. And what happens at negative pi over 2? Isn't that the midline? And aren't I going up and coming back down? So that's a yeah. That's a yeah. Okay, we'll review here. Cosine negative x. Cosine is even. Remember that? It's worth remembering. Cosine is even. And what does it mean to be even? If you plug in a negative, it doesn't matter. So isn't cosine negative x exactly the same as cosine x? Yeah, so that's a yes also. How about sine x minus pi over 2? Now remember, that's going to move you pi over 2 ahead. And if I go pi over 2 ahead, am I a sine curve? Yes, but I am negative. So that's a no. Which means the last one is a yes. Because it is a negative sine curve if you go to the right, pi over 2. Don't just stare at me. Are you digesting this?
Yes.
All right, find the tangent of this angle. That's easy. What's tangent? Y over x. So what would that be? Negative 4/9?
Yeah.
Write the equation of a sinusoidal function with a range of -1 to 7. So the only stipulation is it's got to go from -1 to 7. All right, so think about that. It's got to go from -1 up to 7. Well, what do you know automatically about that curve then? If it's minning at -1 and maxing at 7, then its midline must be 3. The average, -1 plus 7 is 6, divided by 2 is 3. And if the midline is 3, whatever kind of equation you choose to write, isn't it going to have a plus 3 on the end? And, I'm just going to draw one in here randomly. If its midline is 3 and its maximum is 7, its amplitude has to be 4. So would that be an example of one? Now, there are lots of other ones you could have for sure, but you have to have an amplitude of 4 and a vertical shift or a midline of 3. Is that good with everybody? All right, an angle in standard position has a measure of 4 radians. The terminal ray of the angle intersects a circle centered at the origin with a radius of 1 at point A. All right, so that's a lot, but it's easy. We have a unit circle centered at the origin, radius 1. And what do we know? There's our unit circle. What do we know about this angle right here? That angle is 0. What's this angle? Pi over 2, because this is pi, 3 pi over 2 and 2 pi. Right? Now, pi is 3.14. Half of that is 1.57. So this would be 4.71. So the question is, where are 4 radians? Wouldn't 4 radians be right down here somewhere? Quadrant 3. Give the coordinates of point A to the nearest 1,000. So here's my point. This angle is 4 radians, and I want to know my x and my y. Oh my gosh, how do we do this? It's so easy. What do? We need a calculator. What's x? On the unit circle, what's x? Cosine. So we just type cosine 4. Make sure you're in radians. Cosine 4. And sine 4. Cosine 4 to the nearest 1,000, negative 0.654. And sine 4, negative 0.757. Is that okay? We all good? Portion of the graph is shown. On each of the following intervals, determine if f is increasing or decreasing. that is the function. Is the function going up or coming down? And is the graph concave up or down? All right, take a second and fill those in for the given intervals. Remember, it's periodic. All right, did you were able to do this? What did you say about that first interval? What? Increasing and concave up. Now, I don't know what you did. What's the period? The period is 6. Everybody get 6 for the period?
Yeah.
Okay, that'll mess you up if you don't get the right period. You gotta get the right period, 6. And then I just backed everything up for the first one. I backed everything up 18, 3 periods. So I looked at the interval from 4 to 5.5. I'm not saying you have to do that. That was my thought process. And then for the second one, I backed everything up 12. And I thought it was decreasing concave down. And then the last one, I backed up 36, 6 periods. And I thought it was decreasing up. Did I do okay? Don't just agree with me. Is that okay? All right. In the diagram shown, an angle in standard position whose terminal ray passes through C has a measure of pi over 3. All right, before we go any further, if that angle were in the unit circle, which it isn't, this circle is not a unit circle, but tell me about the sine and cosine of pi over 3. So on the unit circle, here's pi over 3. This is the sine, this is the cosine, or excuse me, backwards. This is the cosine, this is the sine. What are those numbers for an angle of pi over 3? 1/2 root 3 over 2. So you know that the cosine of pi over 3 is 1/2. And the sine of pi over 3 is root 3 over 2, right? No question? No question. Now, what happens when you put that in a bigger circle? Then x is no longer, or cosine is no longer just the x coordinate. Anybody remember what the x coordinate is when you're in a different circle? X equals r cosine theta, and y equals r sine theta. So on our bigger circle, what will the x and y coordinates be? 3/2 and 3 root 3 over 2. So that's point C. What are the coordinates of point D going to be? same angle. So what would these be down here on your bigger circle? This will still be 3/2, but this one will be negative 3√3 over 2. And we want to know how far apart those points are. Well, that's easy. How far apart are they? 6√3 over 2 or 3√3? Don't forget this. As much as we love our unit circle, not everything happens in the unit circle. All right, evaluate without a calculator. Oh, we're not going to do all of these, but tell me about sine 15 pi over 2, the last one in the first column. 15 pi over 2, what in the world? What is that? Isn't it too big? Isn't 15 pi over 2 too big? So let's shrink it down. Let's find the coterminal angle. So let's get rid of some extra spins. What is that going to go down to? 3 pi over 2. When you shrink it down, how much do you take out? 2 pi's. So you take out 4 pi over 2. 8 pi over 2. 12 pi over 2. So I'm left with 3 pi over 2. What's the sign of 3 pi over 2? Negative 1. Same thing with bottom row, middle. Tangent 7 pi. What's the tangent of 7 pi? Where is 7 pi? 7 pi is at pi, right? And what's the tangent at pi? Y over x. 0 over 1. 0 over negative 1 actually, but 0. 0. Perfect. All right, letter H. What is the length of the minor arc of the circle from point M to point S? How do we find arc length? Radius times radians. Your arc is radius times radians. So that's just going to be 6 times 7 pi over 15, which is what? 14 pi over 5? Did I reduce that right? And if I had a unit on my radius, it would be that, so inches or feet or something. Remember that 1 radian is 1 radius.
Oh, it's brutal.
1 radian is 1 radius. Right? Of arc length. All right, the equation for the graph is shown. Find the values of G and H. All right, take a second, see if you can figure them out. G and H. G is easy. See if you can find H. What do you think for G? What did you come up with for G? 0.5? Did you say positive 0.5 or negative 0.5?
Positive,
And why did you say positive?
because it's shifted to the right, so it would start at pi over 6.
3. It started at 3 pi over 6. That's a pi over 2, isn't it? This is your shift right here.
Yeah.
So pi over 2 is 3/6.
Yes.
Yeah.
Sorry.
So it's starting here, and that's a positive sine curve. That's exactly right. They're trying to trick you, because if you start here, it would be a negative, but we're not starting here, we're starting over here. All right, what did you get for G? What is your period? The period of this thing is pi over 3. Whatever this number is, 2 pi divided by it is your period. So that has to be a 6. Beautiful.
How did you know it starts at 3 pi over 6 instead of just a 0?
Look at the equation. That's your phase shift. That's your horizontal shift. 1/2 is the same as 3/6. Right?
Yeah.
All right, try J, last one. Try it with your teammates, see what you can come up with while I hand back some homework paper. Unless he's jumping rope.
Does the 2 pi over n trick work for cosine?
Yep. It was for everything that would appear to 2 pi. So it won't work for tangent.
That's what frequency does.
So I wrote up here computer collaboration and not wanting to do it together. Region, okay? And I'm totally cool with it. Yeah. I'm not cool with somebody copying, okay? So you stand, you know where I stand on that, so.
Confidence was not there. There's something where like no confidence in these. Understandable. I had even less confidence in you, like doing it myself.
Okay, that's, I see that.
What kind of progress are you making? Okay, were you able to come up with some points
Always have some friends.
for the jump rope? Let's start with that, because eventually we're gonna have to write an equation. So let's kind of get a visual on this. So, what are our ordered pairs gonna stand for? X is going to be the number of seconds. And Y is going to be
Feet.
the height of point A. So that's B. All right, so what do we know? Where are we at time 0?
See the ground?
It's on the ground. So if it's on the ground, then its height is 0. Now, okay, so you've jumped rope before. Okay, so there it is. So I jump. When does it hit the ground again? When is it on the ground again?
Kind of make it
In 1 minute, Jesse completes 80 jumps. So in 60 seconds, she does 80 jumps. Would you agree with that?
Yeah.
So in 1 second, she does, what is that, 4/3 jumps?
That's such a.
So, wait, I went the wrong way. 1 jump would be
What?
3/4 seconds. I wonder what my period is. So every 3/4 seconds, she does a jump. Right, I divide by 80. So this is 1 jump, which is a spin of the rope. 1 spin of the rope is 3/4 seconds. So at 3/4, it's back on the ground. Now, where is it at the halfway point, which would be 3/8? Where is it there? Wouldn't it be 7.5? Because it's on the ground here, it's on the ground here. Halfway between it would be up here. And then the halfways of these, which would be what, 3/16 and 9/16, would be where?
3.75.
3.75, at your midline. Now, do those points make sense to you? Okay. Identify the maximum value of J. Don't they tell us? Isn't that 7.5? What is the period of J? Well, we already figured that out. Our period is 3/4 seconds. Identify the midline of the graph of J. Well, didn't we figure that out too? Our midline is 3.75. So now we can write an equation. The equation is your model, you guys, and modeling is a big part of what we need to be able to do. We need to be able to write equations for all kinds of things, not just the trig things. So I don't know, it always kind of helps me to maybe see what's going on here. Here's my midline, 3.75. I got 0, 0, 3/16 is here, 3/8, I'll say 6/16 is Alright, so if I look at that, what kind of equation do I see? If I just look at that part of it right there. That is not a sine. That is a cosine. Now, could it be a sine? Absolutely, but I'd have to start looking here. Because sines start on the midline. This is a minimum. So if I choose to start my picture here, I'm going to have a negative cosine. Whose amplitude is 3.75 and whose midline is 3.75. If I start right here, then this is, I have no phase shift. I'm starting right where I'm supposed to start, on the y-axis. If you're writing a sine equation, then your phase shift will be x minus 3/16 if you're doing a sine equation. I don't know what that is, but 2 pi divided by it gives me my period, which is 3/4. So it looks like that number has to be 8 pi over 3. Is that okay with everybody? All right, what we're gonna do in our remaining couple of minutes, I need you to have a sheet of paper. Because you're gonna, tomorrow you're gonna graph for me.
Can we use the back of this?
You can do whatever you want, you're not turning it in, it's just practice. You can do whatever you want. Yeah, the back of the notes has a blank side, so maybe that's a good idea.
Something happened before?
Yep, you're gonna do a graph for me tomorrow.
What we talking about?
So I'm gonna give you an equation,
I'm so excited.
you're gonna graph it, find all the period and all that stuff too, so let's practice, here we go. Y equals -2 cosine 5/8 x minus pi over 4 plus 1. And we're gonna sketch this and list everything. So amplitude, period, frequency, phase shift, which is horizontal shift. This is horizontal shift. And then vertical shift, which is midline. Okay, so we have different words for stuff. Horizontal shift and midline. All right, so I'm gonna sketch it, so. I'm gonna go ahead and put in my midline, which by the way, will be my vertical shift, right? Up 1. Whatever's going on is starting at pi over 4. Would you agree with that? My amplitude is 2, so if this is 1, it's going to go up to 3 and down to -1. Are you okay with that? Okay. And I know it starts here. And I know it's a negative cosine. Where do negative cosines start? At their minimum. So isn't he going to start right here at -1? And he's going to come up, and he's going to come down, and he's going to end right there. He's going to end right where he started at -1. Now, in order to figure out that point right there, what do I need to know? A period, right? And I find my period by taking 2 pi and dividing it by that number. So it looks like my period is 16/5. Yuck. This point right here, is going to be pi over 4 plus 16 pi over 5. Would you agree with that? So let's get a common denominator. So this is 5/20, and that's 64/20. So what is that? 69/20. Not nice numbers, but oh well. We're grown-ups, we got it. Now, right here in the middle, the peak, is going to be what? The average or the midpoint of these two. Would you agree with that? The midpoint? So this is 5/20, and that's 69/20. Added makes 74/20, and half of that, 37/20. This point right here, and this point right here, where we cross the midline, this one will be the average of 5/20 and 37/20. So 5 and 37 makes 42, 21/20. And 37 and 69 makes 106, 53/20. Let's put arrows on the ends here, and our graph is complete. Amplitude was 2, always positive. That number's always positive. Period was 16 pi over 5, and the frequency is 5 over 16 pi. And this was right pi over 4. So tomorrow we're gonna do that for grade. I'd hoped we'd have a little more time. So we will do one more practice problem tomorrow before we take our
We
graphic
had a little
quiz.
lunch period. I
Okay,
remind
are you clear on that?
Joey will be at the chapel for mass at
Yes.
11:50. Please join us as you would like. Now let us pause, be mindful of all of God's blessings.
3/7 is due on
Father,
Monday.
Son, Holy Spirit, amen. Lord, thank you for the food before us, the Irish family and friends beside us, and the love. In Jesus' name we pray. Bless us, O Lord, and these thy gifts which we are about to receive from thy Son Jesus Christ our Lord. Amen. In the name of the Father, Son, and Holy Spirit, amen.
If you have time between now and tomorrow, take a look at those homeworks I turned back and see if you can figure out what in the heck you're doing. Not for you, I'm sorry. I love you. Do something great and I'll make you cookies too.
Who are the cookies for?
We had them yesterday
Oh yeah, I know,
for Declan, for bowling.
that was okay.
Yeah. How did you miss that?
I didn't miss it. I thought you were saying that the extra cookies were.
Oh, no. No. Those were, I didn't have G until today.